right, today we're going to do a demonstration of how we can turn a live stream camera feed, such as this one coming from YouTube, into a dashboard on Snowflake, which is showing us the traffic counts of everything that's come through that intersection today, using nothing more than Snowflake and LandingLens. So we're going to be showcasing an application called LandingLens. This is a native application available in the Snowflake marketplace. And we'll go through this architecture of how the solution comes together, again, using nothing but Snowflake and LandingLens, connecting to that camera feed, and then making that front-end application available to end users. The actual vision model will come from LandingAI. This is where we will label some data, train a neural network, and then deploy this to an API endpoint so that we can interact with it in Snowflake. We'll save all of our inference results into a table, which we'll create views from in Snowflake. So here we've got a nice structured result of all of the passenger cars that have been detected, and exactly where in the image they've been detected, associated with that date timestamp. And once we get this all working, we'll be able to connect it up into a Streamlit application where we can see not just today's information, but also historical information. I'll go ahead and zoom into a more recent time period here. So we've got some historical information by the hour or historical information by the day. And that's what we're going to build. So let's start off with a closer look at the structure here. So we've got a camera feed. In this case, we're going to be using YouTube. And we're going to write a little bit of custom code to collect some training images. Now, luckily, that exact same custom code can be used again later when we do inference on those images. So this large outer rectangle is Snowflake. So now we have our training images inside a Snowflake stage. And from there, we'll bring them into LandingLens. This is where we'll do the labeling and the vision model training, and then deploy that to an API endpoint. Once we have that endpoint available, we can gather our images for inference, send them to that endpoint. That's going to give us an inference result in JSON. We're going to parse that JSON and store it in a table, and then do some aggregations to store an analytical view from that. Then we're going to use Streamlit in Snowflake to create a front-end application that draws from that view. My particular demonstration doesn't use any other data from Snowflake. It just uses the traffic camera information, but it would be very easy to bring together other things in this front-end application and then make it available to users. And the cool thing about this is basically all happening in real time. So I've got a script running on my computer connected to this camera feed, and the users are basically able to see, within a couple seconds, anything that has actually gone through that camera being counted in the dashboard. And it uses only these two technologies. Okay, so I'm going to pick up the story here from training images that are already in a Snowflake stage. You'll get to see the code later when we do this part, so I'm going to skip the code that actually pulled out the images, and we'll just start from this step and we'll move forward. All right, we've created a new project in LandingLens, and we are running inside of Snowflake. We're going to build an object detection model for all those different things in the intersection. And we're going to start by syncing some Snowflake data. So I already know the path to my stage, so let me start typing that in. Oops. All right, and I've got a folder here called data with just 100 images. So let's go ahead and sync those. Okay, great. So let's scan through some of these images, and let's start with something easy like this school bus. So we're going to need to create a class, and we'll call it school bus. I'll choose yellow, makes sense. And then we will annotate the school bus directly here in the user interface. Okay. And And we might create another class, call it truck. I'll make that magenta. And we'll mark the truck in the user interface. Now this seems really tedious, especially when you start getting into passenger cars. But let's create a passenger car. And we'll make those royal blue. And the reality is once you get pretty fast at this, you get pretty fast at this. This is a task that you can definitely assign to an intern. And the good news is that you only need a very minimal number of images to get started. So we'll need about 10 images where you've correctly labeled everything in the image. And then you'll actually be able to use the label assist to make the labeling go faster from there. Now, notice that I have not labeled any of the parked cars because I'm only interested in the vehicles moving through the intersection. And I've also created a rule for myself that I don't care about anything behind this cross street. So I'm not going to label any of these moving cars, which are actually behind this cross street, and that's going to be my visual reference. So I've done one image. Let me go ahead and advance to the next one. Okay. I got one truck in this picture, multiple passenger cars, and I think you're probably starting to get the hang of it. So let's do the kind of classic cooking show fast forward, and we'll go to a project that's a little bit further along to see what this is going to look like. Okay, so this project has 562 images, and quite a few of them are already labeled. So we have over 4,000 passenger cars labeled, 77 school buses, and you might be saying to yourself, oh my gosh, that seems like a crazy amount of work to draw boxes around 4,000 passenger cars. So let me show you what the label assist is going to allow you to do. So in this project, there are 500 labeled images and 62 unlabeled. But remember that I said you could use the first 10 to make the process go faster from there. So here's an image which is unlabeled, which I can tell over here from the right-hand side. But I've already developed some preliminary models. So now I can use this get predictions to make predictions about what it sees in the image. And then I can accept these predictions as what's called ground truth. So all of this actually looks pretty good to me. I can adjust the confidence threshold for how confident the model needs to be to kind of add these predictions. And I'm going to go ahead and say accept all. So once I accept all of them, then I can still make adjustments to them. So for example, I'm noticing that these two vehicles back here were actually predicted as 1. So I'm going to remove those other boxes and I'm going to draw 2 separate boxes there. But otherwise, everything else here looks pretty good. So we can go on to the next one. And again, we'll use the label assist, get some suggestions. I'm going to go ahead and accept all. And then I can make any adjustments I need. So this one is being predicted as, this is my color for other oversize. So I know that from this project, so that that medium blue is other oversize, so that's the correct category for this vehicle and the correct category for this one. So all of these actually look just fine at this point. So that is basically the class creation process and the labeling process. So now I've got 502 images labeled, 60 unlabeled. And I can go ahead and train a model from this. So because this project is my kind of existing demonstration project that actual dashboard is connected to, you can see that multiple models have been trained. So the one at the bottom of the list here started with just 100 labeled images. Here we're up to 270. Now we're up to 351. And we're going to go ahead and train one more. Because now we're up to a few more. So I'm going to choose the custom training options here just to show you what's available. I do need to assign a split to some of my newly labeled images. And Then I can choose some of my model hyperparameters. So this is where I would rescale or crop my images if necessary. I'm also going to add all of these augmentations. And this is a good chance to preview some of the augmentation effects. So this might be a little bit small, but you can see how the augmentation is actually modifying the hue, the saturation, and even the real colors associated with the images. And all of these are user configurable, which augmentations you want to use and what boundaries do you want to set. I am specifically not doing things like horizontal or vertical flip because it's a fixed camera, so I want to keep that perspective, but all of those are options available to you. I can set my training epochs, I can choose my model size, and when I'm done configuring the parameters, I will click Train. So because we are in Snowflake, this is now going to spin up a GPU using Snowpark container services. You do not need to do any sort of infrastructure provisioning or GPU provisioning. This is going to take a few minutes to spin up because it was asleep. And then as soon as the GPU is spun up, then the training and learning will start. While that's happening, we can take a look at our most recently completed model. So let's take a look at the confusion matrix. And actually, I'm going to view it from this page and go full screen. Okay, so these are the training epochs. It's keeping track of the loss with each epoch, and of course, lower is better. Here we've got the mean average precision, and of course, higher is better. And we've got a record of all of the parameters that were used when we trained that model. Then on the performance report, we get a multi-class confusion matrix, and confusion matrices can often be quite confusing. But the main thing we're looking for is all of these predictions that fall on the diagonal. Here's something off diagonal, this 5, where the ground truth is bicyclist and the prediction is pedestrian. So we can actually click into these 5 and then see those specific images. So here we've got ground truth is bicyclist being predicted as pedestrian. I think this is actually wrong on the ground truth. Let's go ahead and fix that. So this actually happens all the time when you realize it's not the model that was wrong, it was the human that was wrong. Where is the bicycle? Oh, somehow this person got labeled as a bicycle and a person at the same time. Okay, well, we can fix that. So we do need to bring up our tools here. I'm gonna remove the bicyclist, which is like the slightly darker color, and then I'll put the pedestrian box back around that person. All right, and notice that the labels are now saved. So I can always go back and view my previous project, and let's go back in here. There is a faster way to navigate to this. I probably should have gone a different path. Okay, here's our 5 images. So here was that instance that I just edited. And when I come back to it, you'll see like you are viewing the snapshot. The ground truth of this image has changed since the snapshot was taken. So this is actually very important for kind of tracking and record keeping purposes, that you know what images and what labels were used to train each model. But I didn't even know about that error, and luckily we were able to fix it. And it looks like it's recurred in this image, and this. No, this one actually is a bicyclist. So let's take a look at this one. So here, this really is a bicyclist. It's being mispredicted as pedestrian. We can take a look at it to see it a little bit larger. And so this is a case where the model is wrong, not the human is wrong. So that one is clearly a bicycle. Yeah, and it's correctly labeled as bicycle, but it's being predicted as pedestrian. So this is why we want to collect more images over time to improve that model performance. Okay, so we still have a model in progress. Let's show you a few other things here on the performance report. So we can toggle between the training set and the development set. Generally, you'll see slightly higher errors in the development set, and the confusion matrix makes it very easy to kind of click into any of these and understand what's going on. Notice that there's an additional column here for no prediction. So we've got examples where, passenger cars and trucks, there's 45 cases where there was no prediction. And I know from experience that this happens usually when there's two vehicles really, really close to each other, and one is almost completely obscuring the other. Here's also a nice example in the snow to encourage you to collect day and night images, cloudy and rainy images. Can't all just be bright sunny days. So there are indeed a few cars missing in that prediction. So I clicked on the wrong thing. I meant to be looking at these 45. So here's our false negatives. So the ground truth says there's a passenger car, but there's no prediction being made. And as I mouse over these, you can see which specific ones. So this one down here is being labeled, but you can see is not being predicted. And then there's these two cars over here that are just coming in from the right-hand side. They are also not being predicted. So this is a case where the, more than half of the car is missing. And here's an example, I think, where the model probably just hasn't seen a lot of pictures in the snow. So I think that that's actually probably the problem there. What have we got here? So this is one where two cars are very close together. It's missing one of them. Multiple cars in a row, it's missing one of them. But across hundreds of images, the fact that these are the only ones that are being missed is actually pretty darn good. So that's basically how you can use the performance report to understand what the model has learned, where it's making mistakes. This can help you select images for retraining purposes. But let's go ahead and, oh, good. And our model has started training. So let's take a look at the details here. Okay, it started. So we're on epoch number 2, and now this is basically going to run on its own. There's nothing else you need to do. You just come back and check on it when it finishes. So going back to our architecture diagram here, where are we? So we are currently here. Our vision model is training. We're going to have to wait anywhere between about 45 minutes to an hour for it to finish. That's going to be based on the pixel size of the images and also how many there are. And then the next step is going to be the API deployment. So let's pick a previously completed model and we'll go ahead and do that step. Okay, with our one model still in progress, this little icon over here means that these models have been previously deployed, and these 3 at the bottom have not. So let me just show you how that works. So I'm going to click on deploy, and we do offer cloud deployment or self-hosted. In this case, when you choose cloud deployment, that is staying within your Snowflake environment. And I will go ahead and deploy it to this kind of testing endpoint, which I intend to delete later. You can always create a new one if you need to. And that has now kicked us over to the deploy area. So notice here on the left-hand side, we are in deploy. And this is giving us the information we need to now interact with this model programmatically. So the endpoint has been created. And we have 2 options for how to interact with it, either as SQL inference in Snowflake or using the Python SDK. So everything we've done so far has been low code or no code, but now we will switch over to using this endpoint, and we'll use it programmatically to connect to this live feed. Take a new picture, send it to that endpoint, and then save that information for inference. So on our diagram, we have now completed the deployment. The API endpoint is ready to go. And now we're going to shift over to a notebook. And what you're going to see is this chunk of code, which actually does this step to grab the image for inference. It does this step to send it to the API endpoint. And it does this step to save this inference result. And it's set up in a loop to just do it again every 10 seconds. So every 10 seconds, that code is going to run this portion, and it's going to accumulate a repository of images, and it's going to accumulate a repository of results. So let's see that happening. Okay, so this looks like a fair amount of code, but there's actually just a lot of exception handling here. So the core pieces of the code are actually relatively straightforward. So we start off with our secure Snowflake configuration. We're using a private key, which I have stored locally, and I'm connecting to my Snowflake account as a specific user. This is the same URL for LandingLens that we were using previously to access the graphical user interface, so same URL that you're going to post here. So I've got which warehouse do I want to use for the compute, my database and schema, and then these standard connection parameters, which is provided by Snowflake. And here I'm actually making the connection to Snowflake. So everything in this first section is about kind of the configuration and the Snowflake account access. All right, part 2, LandingLens inference setup. So this is the endpoint that I want to use. If you want to use a different one, it's as simple as changing this string. And then this is the function that we provide in our SDK. So you may have seen up here at the top from LandingAI predict import Snowflake Native App Predictor. And so that's what you're seeing here is this predictor is the Snowflake Native App Predictor, and it needs this information for authentication. Okay, so that's the LandingLens inference setup. Stream and directory setup. So which YouTube URL do we want to follow? What's the height and width of the image? This just automatically goes 9:16 based on the width you enter. Here's where I can say how many pictures do I want, how much time do I want in between. I am saving them also to a local directory on my computer, which is an optional step. And then here is the name of the stage where I want to put the image, the name of the table where I want to put the structured result. And this is the pattern that I want to use for my file name. And I'm just using like date, month, year, timestamps. You'll see that in a moment. This looks complicated, but this is really just about being able to find images easily later. Okay, we've got a couple utility functions that have nothing to do with either LandingAI or with Snowflake. This is just a way to convert that YouTube stream into something that I can access locally on my computer. And then here we're going to capture and save a single image. So these are really just functions that are provided to interact with video streams and with YouTube. All right, and here's the part where we're actually going to send some images. So we're going to connect to that YouTube URL, log the start time just for record keeping purposes, and then we're going to go through the number of iterations we specified previously, which was 10. So first, capture and save the image, and it's going to save that locally in a directory. Then we've got image equals open image. So after we've saved it locally, we open the image. This is just about giving it a name. And then here, predictions equals predictor.predict image. So this is the part where we're actually doing the inference on the image using the endpoint. So all of this code actually kind of wraps around the magic of line 138 here. So this is the line that actually does the prediction. Okay, what we get back is something called predictions. And then here we've got the upload command. So we're using put to put the image into the stage that we specified previously. And then we're going to unpack the predictions object. So if there's a car, truck, school bus, something else detected, for every object in predictions, it's going to insert into that table name the structured data that we want. So what's the file name, endpoint name, blah, blah, blah. What is the label of the thing that was found, like a passenger car or a school bus, confidence scores, and so on and so forth. And then it will sleep for the prescribed number of seconds, which we set as 10. It'll close up the connection to Snowflake and it'll print the end time. So that is the walkthrough of the code. So hopefully that was not too scary. And now let's actually see it run. Okay, so let's see it actually run. So I am in the correct directory. I'm going to type Python 3 YouTube inference 4corners.py and let's see what we get. Okay, so as this is running, you should actually be able to see the timestamp on my computer. It's 4:04 p.m. And here are some images that are now being captured every 10 seconds. And we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that should be the end of the loop. These are the 10 images that we have just captured. We can take a look at those. All right, not too much happening in the intersection right now, but that's okay. So let's go back to our architecture diagram. So I told you that the code we were just looking at was doing this sequence. Grab the image for inference, send it to the endpoint, and then save the inference result. And you saw the images being saved on my local system. But now let's go into Snowflake and we'll look at this stage and we'll look at this table to see what's new there and see if we see any new images and new inferences. Okay, so here is our Snowflake databases view, and we've been inserting images here into inference images all, and we've been inserting the objects detected, into this table, into objects detected. So let's start with inference images all. You can see there's currently 1863 in here, and I'm going to click this little refresh button. And indeed, we've got quite a few more, and here are some of the ones that we got just in the last few minutes. It looks like this is overlapping with the regular job that is running, so it's a little bit hard to distinguish the 10 that we got just now from the loop. We could, I guess, compare that to some of these file names. So let's see, the last one here is 16-05-16. So just to prove that this is actually all happening, it's right here, 16-05-16. So that was the last one from the loop, and it's overlapping with some other cron jobs that are causing other images to come in. Okay. Now let's take a look at objects detected, and we'll go over to a worksheet, and I'll just briefly show you the setup here. So a couple things to know. So we did need to create that stage inferences all, and then we do need to give read access on that stage to the application called LandingLens Snowflake. And then we need to create this table called objects detected. And then we'll also be using this view, the objects detected view. But now we can take a look at what's in objects detected as a table. And this is going to have one row for every object found. So here's actually that last picture that we had from my local computer. This one's 16-05-16. So it looks like this one only had one object found, was one passenger car. So it only has one row here in the table. The picture above that, actually, you know what? It's just not being sorted correctly because here's another one and here's another one. So anyway, there should be one row for each object found. And then this Snowflake view just adds a little bit of additional information. So in the view, I added things like what day of the week is it? And that's going to allow us to do some interesting analytics downstream. But fundamentally, the code that you just saw grabbed a picture from YouTube, it sent it to the API endpoint, it saved the image itself in this Snowflake stage, and then it saved all of the objects that it detected in this table. And then we have this view, which is created by aggregating some items in the table. And it's actually the view that will connect to the dashboard. So, coming back to this diagram, we've now demonstrated that this part is indeed working, and this part are indeed working. So the only thing left is to create the front-end application and connect it to this analytical view. So let me wake up my Streamlit app. And we should see our count go up here from the time that we started the video. There we go, 339. So in the time that we've been recording this video, or I've been recording this video, there were the 10 that we sent manually in the loop. And then also there were 29 others that were sent based on other jobs we have running to kind of keep this demonstration populated. So let's show how this works. So we're going to go ahead and click Edit here. And all of this is basic Python code, and this is all provided by Streamlit. So we've got a function here called fetch historical data. And that just goes into a table that I didn't show you, which I will backtrack and show you. So this is fueling the historical view, and it's performing some aggregations in advance. That way the Streamlit app itself doesn't have to do these like hourly or daily aggregations. So those are done ahead of time in this view. But I did show you this one. So here we're doing fetch current data, and we're connecting to this objects detected view, which I did show you previously. Everything else is just basic Python code to be able to display the visualizations however you like. I do really like how easy Streamlit makes it to build these things. So we've got, basic charts provided by the Altair package. We've got, some basic counting going on here. And then I did also just include publishing the raw table, because I think just seeing the table helps understand how the app is created. And this is that table that I didn't show you before. But this basically says for each label, for each hour, it's going to aggregate how many of those it has found. So this kind of fuels the historical stuff. So I only have access to the code because I'm an admin on this app. Otherwise, the end user would not see this information. Keep clicking on the wrong thing. The end user would only see this app, and I can click this share button to decide who I should share this with. So they're not going to see the code, they're just going to see the app. And just in the last couple minutes, we should have collected some more images. This kind of depends on where in the job sequence we are, but I'm going to take a chance here and click refresh data and see if we have any new ones. So this kind of completes the story of like this dashboard is connected in real time to this camera feed, and you can refresh the data throughout the day to get a constant count of how many things are happening in this intersection. So it is later in the afternoon. I'm on Pacific time. I think Michigan's on Eastern time. So not as many vehicles coming through the intersection. And I did probably miss that there aren't any new ones, but just for kicks, let's run this script one more time, and we'll see a couple new ones come through. Okay, so at the very minimum now, we should see 10 additional images as long as we allow like 100 seconds to go by. So I'll wait, and then we'll hit the refresh button. Okay, we should have at least a couple new ones, so let's go ahead and refresh this. There we go, 347. So that kind of completes the story on all of these things are connected in real time using a tech stack that consists exclusively of Snowflake and LandingLens and a little bit of custom code that we had to write to connect to YouTube and then connect to Snowflake and kind of put everything into the correct place. So I hope this gives you some inspiration for this is an approachable problem. It is something you can do in a couple of hours, at least to get the pipeline working. And then a matter of getting a good vision model is going to require a little bit of data collection and a little bit of refinement over time. So thank you so much if you made it to this point in the video. This is a generic process that can be used for other video feeds as well. We've got like a fun demonstration connected to this doggy daycare somewhere in Utah where we're monitoring some employee productivity. We've got some YouTube live streams coming from Thailand where we're looking at are the people on the street paying attention to a particular sign or not? So here's a group that is looking at the sign. But this is also, coming from a live feed of this whole area. And another fun demonstration from the Namib Desert. And let's see if I can find it down here. And this is perhaps my favorite of all because we get to monitor some great wildlife in a location that few of us would probably ever get to visit. So this is a fun project. Camera runs day and night. We can work with infrared images as well. So instead of counting cars, we can count zebras and giraffes and other great animals that visit this watering hole. So thank you again for your attention on this video. If you have a camera that you want to get more intelligence out of, take a look at this combination of Snowflake and LandingLens. The architecture, it really is quite simple, and a lot of this starter code is available to help you accelerate even further. Have a great day.